So what are we gonna check out today? First of all, I'm gonna give a real quick intro to what version control actually is. Okay, Git is a version control system. What does that actually mean? Why do we need it? What's it gonna be? And then we're actually gonna have a bit of a hands-on session. So I'll be doing actually live coding from the terminal. I'll be showing off how Git works, what you can do with it, what could go wrong, possibly. We'll see. You're encouraged, if you have laptops, to try at least to follow along, I guess. You can find the slides on here. Yeah, there's code samples and everything, so you can check it out later as well if you want to. And yeah, a couple of other disclaimers. Yes, no questions, please. Thank you. Questions at the end, and we'll also have some time maybe to figure some stuff out. If you have advanced questions, just come to me afterwards. Last thing, I already said this is like a beginner's talk. Okay, I don't know, maybe quick show of hands. How many people are new to programming, have now worked with Git, for example? Is there anyone that has never worked with Git? A couple of people. Who's a Git expert? Who knows everything there is about Git? I don't believe you. Yes. Nobody does. Okay, so it's a beginner's talk. It's for beginners, so if you already know a lot about Git, if you've used it professionally sometime already, there might not be that much new stuff, but you never know. Maybe you learn something new as well. All right, so that's with the intro. Let's get started with the content. What is a version control system? Okay, what is version control even? Git is a version control system, but what does that do? What does it mean, version control? So version control is, thanks Wikipedia, the management of changes to documents, blah, blah, blah. So you manage changes, okay? What does that even mean? I like to say version control systems allow us to track what happens, when, and where, and who did what, okay? It's also a bit abstract. So version control systems, Git is a version control system. To illustrate what they are, they're not actually intrinsic to programming. You don't have to be a developer or programmer to use a version control system. There's version control in other places, for example, Google Docs, right? Google Docs has built-in version control. Yeah, you don't even have to activate it. I think you just have to find the menu point somewhere, yeah, figure out where it is, and then you can have a look at what your document looked like through time. You see on the right-hand side all the versions that there are for this document. You can see who made changes and which changes they made. So for example, we're on the version for February 28th right now. We can see Melanie and Justin worked a bit on that document. We can see Melanie changed some headers here and Justin added some stuff over there. And yeah, we can navigate between those versions. We can go to another point in time, check out the version of the document over there. We can even go restore this version and yeah, basically reset our document to that. So it allows us kind of to time travel and to see what happened in time. Now, what good is that for you as programmers, right? We're not developing in Google Docs. What's in it for us? So imagine this. You're working on a project. You're having fun. You're coding along, sitting there happily. It's all good. And then you hit refresh or recompile or whatever, and everything's, can I swear? Probably not. Okay, everything is broken. It's done for. You don't even know what's happening anymore, okay? Now, what version control system allows you to do is actually check out what you did. Like, say you've been working on this thing for half an hour. Maybe you can't remember every tiny change. Something might have made some change somewhere you can't remember, and that broke it. Version control allows you to see that. It even allows you, well, if you figure, okay, these changes are just dumb, I don't like them, they broke my project, you can just throw them away. Go back to the recent version of your project that you know still works, and that's cool, right? Or what happens more often than you would like, you work with other people and they break your project. So you can actually see what they did and how they broke it, and then you can yell at them or whatever you like. Or just throw the changes away. No, probably shouldn't, though. Okay, so what tools do we have? How can we do version control as developers? There's a couple of options. The main ones, Not sure if you can read that. There's Mercurial, there's Subversion, and there's Git. Okay, the first two I just mentioned. I'm not gonna go into them or the differences. If you want to ask that later, I can answer that. But we'll stick to Git for now. Why? Because Git is I think the most widespread version control system there is today. It's very powerful. It's can do a lot of stuff. It's also pretty complicated at first. So another good say validation or reason for this talk to be here, because when you get started with Git, it's kind of hard, I think, to grasp what is even going on. So that's where we're going to start a hands-on session. If you don't already have, make sure you download Git. You obviously need to have Git installed on your computer. Just Google, download Git, whatever. It's available for Linux and Windows and Mac and everything. If you haven't already, you also have to type in these commands to configure Git locally on your computer. And then you can get started, which we'll do. Can you read that? Good enough? I like dark terminals. So, yeah, so what's the setup? The setup is we're working on a project. We have a project, we have some source code, but we actually don't right here because this is just a demo. I'm not going to show off any source code. I don't have any JavaScript or C++ if you're into that to show off. We're just going to do a dummy project. The first thing you need for a project is a project folder, right? We're just going to create one. You can create that any way you like. I'm just using the terminal, type in make directory, make dir, and our project folder. So it's very creative. It's called my project. I don't know. And we'll just create that. And then we'll navigate into that. So we're in there, change directory, go into the project. Cool. So, okay, we have a project. There's nothing in there yet. So the first thing we'll do is create a file. You can do that if you follow along or whatever later. You can do that any way you like. You don't have to use the terminal. Just use whatever tools you're comfortable with. So we'll create a file with content in it. And the file is going to be new file, right? So create that. Check it if it's there. ls gives us the directory contents. It's there. That's nice. What's in it? We can show what's in the file using cat. Has nothing to. Does anyone know what it stands for? What cat stands for, actually? No, not that. Pretty sure not that. I don't actually know. That's concatenate. That's the backend developer. That's how I know. So show what's in the file. It's content. All right. So at this point, we haven't done anything with Git yet. But we will now. The first thing we need to do is git init. What git init does is basically it initializes what we call a repository, which is like a, let's say, database that Git uses to track your changes. Okay? So let's hit that. Git init. Oh, shit. I wanted to ignore the yellow stuff, please. I wanted to disable that. Kind of forgot, whatever. It just tells me that I should use my aliases. All right, so it says initialized empty Git repository in our project. Cool. So now we have a project repository. What can we do now? Well, we want to create some versions. We want to track what's going on. And the thing with Git is it doesn't do that automatically. When you work at Google Docs, it just automatically does it like periodically on certain changes. I'm not sure. Just creates these versions for you. You're a programmer. You don't do stuff automatically. Oh, you do, but in this case, you'll have to do that yourself. You'll have to create your versions yourself. And before I do that, let's see what is going on in our repository. Because Git gives us Git Status, and that shows us what the current status of the repository is. Pretty obvious from the name. And there's some interesting information that we maybe don't know what to make of it. We're on branch master. We'll get into that later. There's no commits yet. Commits are names for versions. A commit is a version. And there's some untracked files. There's a new file. We created that, but it's not tracked yet. There's no versioning information for it. And Git is nice enough to give us some info like, OK, use git add to create a new commit for this file. So we can do that. Let's do that. So git add new file does something, and it does add the file to what's called the index or staging area. So let's go here for a second. The thing is, this version creation process is not that simple. When you do git add, you don't want to create a version for like one change in one file. You want to bunch those together. You want to collect what you want to have in a version. The way to do that is you work in a working directory, right? You make your changes, then you select changes that you want to create a version from, like git add. You can do that repeatedly. You can do that for multiple files. You can add stuff to the index, whatever you like. And once you're happy, they get added to the staging area. Once you're happy with all the changes that are in there, and you actually say, okay, this is what I want to have in my version, in my change set. This is what I want to show up. Only then do you do git commit, and only then it's committed to the repository. It's made permanent, part of the version history. So we have added the file. We can run git status again, see what changed. And now we see that, okay, there's stuff in the index. The new file is in the index. We can now commit it. So let's do that. We run git commit. We give it a nice message. Add new changes. Very helpful message. Please make your git commit messages helpful when you work with Git. You don't want to add stuff or whatever. Anyway, we commit that. And some more interesting stuff happens. So now we see that it tells us there's a new root commit, root because it's the first one. There's new changes, and even what changes were made. There was one file changed. We know it's new file. There was one insertion. So one line added. And now that we have stuff in our history, we have some versions, we can have a look at those. We can do git log. And I think, yeah, whatever. I haven't set my email properly, doesn't matter. So we can see what the commit is. There's a hash, that's an identifier. We can see who the author is, that's me, when the commit was made, and what changes that were made. So that's one. Let's add another one. You know what? I'm not happy with my document. We'll overwrite what's in there. So we'll make some changes to source code, overwrite the first line with echo content, with content exclamation mark, and also add more content. We'll add more content to the file. Have a look at it, just to be sure. Right, so there's content and more content. And if you have a command line integration thingy like me, you can already see there's like an exclamation mark. And that tells us, well, we modified the new file. It's already in the version. Git knows about the file, and it can see, it already figures out, well, you made some changes. What do you want to do with those changes? Do you want to git add and git commit? It's very helpful if you read it. Another nifty thing, now that we have a previous version of that file, we can do git diff to show, well, the difference between stuff. So we can see that how we have modified new file. And I think you already can see that this is super helpful when you're working and you make some changes to base what did I actually change? In which files? It will give you all the files, it will give you all the changes, and more often than not, you probably made some stuff that you don't want to be in there. If you're like me, I like program like a madman and make changes everywhere, and half of the time I throw half of them away using this, right? So we can see the diff. We're gonna add the changes again. Gonna do add new file again, add it to the staging area, and then commit it again. Add more changes. Cool. And with git log, we can now see there's two versions, right? So there's one where we added the initial one, new changes, and the latest one with more changes. Cool. So we have some versions. That's pretty cool. We can see what happened in a project. We can follow it through time. It's pretty hilarious, actually, when you start on a project that's been running for a long time, to go back. So we'll see in a second how you can navigate those. Okay. But it's pretty hilarious to go back to commits that are like 5 years ago and see what people did there. So this allows you to do that. I recommend it. Just do git log and like scroll a bit and see what people wrote and did. Cool. So we have changes. Now what do we do with those? Like just having changes is okay, that's fun, but kind of lame. The first thing we want to do is go back. We want to go to a specific version. We want to go to some place in time. Let's say that's our latest code base, our latest state, and it's kind of broken. There's some bugs in it. Maybe we want to know if the bugs also happened in the previous version. Are the bugs in add new changes? Well, we can check out. We can go to that version, and we can do that with git checkout. And we give it the hash, the identifier. There's other ways to do that, but in this case, we tell Git, okay, the changes you have over there, please take them, put them in my folder, apply them to my working directory, make my current folder look the way it looked back then. When we run that, ignore that, it's a lot of stuff, okay? Doesn't matter. When we run that, we're on that version. So what is the content of new file right now? Should be pretty clear, right? Content. Yeah, we made some changes, and now they're not there anymore, because back then the add more changes line wasn't there. Now this is not permanent, right? We're on this version temporarily. We can go back to the most recent one with just checkout master. And if we go again, show what the file contains, it's the same. And if we inspect what the history looked like, well, it's still the same. We didn't change the history, we just went back to that commit temporarily, just for funsies. What if add more changes is complete garbage? Okay, some friendly developer developed that. I'm trying really hard not to swear. It's not usual for me. Okay, it's not good. It's really not good. Add more changes you don't want that. When people come to your project and just download your project, you don't want them to have this change be the first thing they see. How can you undo that? Git gives you a lot of options to do that. Some are more complicated than others. What we are going to demonstrate is Git Revert. What Git Revert does is it takes a commit hash, like the one we have here, and it basically just undoes exactly those changes. So it will look at the change set. If you added a line, it will exactly remove that line, and it will create a new commit from that. I can't even remember right now what the flag was. No skip commit message, something like that, doesn't matter. So now we'll ask me, give me a commit message. We'll give it that real quick. You can actually tell Git to just use a generic commit message. Gotta remove the tags. Okay. So what does git log show us now? New commit, right? We have reverted the changes. We're on the latest change, and the content of a file is, again, content, because we undid the whole add more content stuff. So that's how you can navigate between commits and also how you can undo stuff. Okay, next thing on the list, branches. Branches, who knows about, everybody that uses Git uses branches, right? Everybody. Does anyone use Git and not use branches? No, right? It's an important concept, and it's also kind of tricky to understand when you're a beginner. So what a branch allows you to do is actually, as the name suggests, you have this commit history. You have this, let's say, list of versions. It allows you to go away from that and do your own thing, to work in isolation. You can still do commits, you can still create versions, but you're not interfering with anybody else. You can, for example, start working on a feature, you're branching off, you're just doing your stuff, working on your feature, and the other developers that work with that code base they're not seeing that pretty much. They're not, they simply, they don't see your changes. They're not, whatever. All right, how can we create a new branch? We can do git checkout, B, and then the branch name. So we'll call ours feature 1, right? And what happens now, if you look at git log, all the changes that we had on master are still there. If we go cat new file, show what's in the file, it's still the change, because that's where we branched off. We branched off from master. But all the changes we make here are limited to that branch. Is a bit of something to visualize. That's really hard to read, okay? But the idea is you have the green line, that's the master branch. You have a bunch of commits on there. Now you can go away, it has 4 files. All of those are on version 1.0 in the beginning. Now if we branch off from that on feature 1 and we make some changes, we update 1 and 3 to some version 1.1.1 or 1.1. If we're still on master and we're branching off from that, feature 2, at that point in time, feature 2 doesn't have those changes. The files are still on 1.0. And you can make other changes. So feature 2 changes files 2 and 4 to 1.1. And only when those changes get merged back together, then they merge together. Then you have them on the master branch. But before the merge, not there. You can experiment with features that way. You can just branch off from master, do your thing, nobody knows about it, and then maybe throw them away, or if you're happy with them, merge them back. So we're on feature 1 right now. Let's add some changes the usual way. We'll do branchy content and add that to our file. So the file contains now content and branchy content. You know the spiel. It's git add new file and git commit m and add branchy content, right? So our log now shows that we have some branchy content in there, right? Great. So, but that's feature 1. Let's go to back to the master branch, and we can do that with git switch. Git switch is actually fairly new. Most of the experienced Git people already know that there's you can do the same thing with checkout, but Git recently introduced git switch specifically to switch between branches. So you can use git switch and give it the branch name. And now we're back on master. Now what do our changes look like? If we go git log, no, our changes are not there. The branch content is not there. Why? Because it was on the branch, right? The content, there's no branchy content. Why? Because the changes were made to the branch. We're still on the same directory. Exactly where we started. We just used branches to make changes in isolation. And that's super, super powerful, even when you work alone, not with other people. How do we get those changes now? We can actually go Git Merge, as I hinted before. It's called a merge. And then you give it the name of the branch that you want to merge. So you're on a branch. You will need, there's other ways to do that, but in this case, when you give just one branch name, Git will try to merge that branch into the branch you're currently on. So switch to master or the branch you want to merge to, and then give it the name of the branch. Feature 1. So let's do that. And Git tells us some stuff. It says fast forward. That's the way it resolves branches in this case, because we didn't make many changes, just fast forward. And what changed? We added one line to new file. Git log will now show us that this commit is in there. Why? Because we merged it in there. Cool, so I hope you can see how you can isolate changes and how that helps you as a developer, right? I think it should be pretty clear. Last thing, okay, I'm not sure, it's kind of hard to, when you've worked with Git for a while, it's kind of hard to say how easy it is to understand that kind of stuff. So I hope for the people that are new that still makes kind of sense, all right? If not, just ask me later, come talk to me. One last thing, I know there's already a bunch of content, but one last thing I want to talk about is Git Remote. So everything we did so far, is there still time? Right, yeah, cool. Okay, so everything we did so far was limited to our machine. There was no sharing code or anything over the internet yet, okay? Super powerful if you work alone right here, but more often than not, you will work with other people. You will want to share what you did. You want to share the code you created. You want to share your versions. You want to share the changes that you made. So how can you do that? Git is a distributed version control system, and that means that there's no distinction between where repository is. Yeah? Everything is a repository. You can have a repository on your machine. You can have a repository on some server somewhere, and those can talk to each other. You can even create 2 repositories on your, let's say, in different folders and have them talk to each other. Okay? So what we need right now to share code with other people, to share version history with other people, is a remote repository. A repository is some place on the internet. There's a nice place for hosted repositories, and that place is GitHub. Okay, GitHub is a service that basically gives you free hosted repositories. It's also a social platform and stuff. But for our intents here, it allows us to have a repository like we had on our machine here, but somewhere on some server in the cloud. No. We're gonna call that my project. Yep, that's what I thought. My project 1, name doesn't matter. And we can choose some other stuff which we don't care about right now. We'll create the repository, and it's important to understand, even though this is like a web interface, I'm pretty sure that GitHub does nothing other than simply do a git init somewhere in the background. The same thing we did in the beginning. So we create the repository. Now Git tells us, okay, cool, there's a repository, right? My project 1. And it tells us how we can reach it and how we can sync up with it. We already know the stuff that's down here. We don't need to know that. So we'll copy this link, and then we'll go back here. So what we want now is tell our local repository about that other remote repository in GitHub that's on some server. How do we do that? We do Git Remote. Git Remote, right? Git Remote add, because we want to add a new remote. And then we give it a name, origin. And that's just the name. That's convention. The usual first remote that you use, you call origin. And then you paste in the link where can Git on your machine find that other remote repository. I hope I got the command right. Yes, perfect. So Git should know about your remote, and you can see what remotes your repository knows about by running git remote v. And it will say, okay, you have 2 remotes actually. You have one for fetching, that is getting changes, and one for pushing changes, which we'll do in a second. So push is the process of putting your changes over there, and we'll do that right now. We'll do git push. We give it where we want to push, that is origin, right? If we say origin, Git knows, oh, okay, he means that identifier, that URL. And then we give it the branch that we want to push. Okay, let's do that. Git push, where, origin, what, master, our master branch. And then some stuff happens, data compression, blah, blah, blah. Bunches everything together, so it's small. And where to GitHub and master. And now, if we go back here and we reload, bam, we have our changes over here. And you can, obviously, this is public. So if you go to Harshni, my project 1 right now, you will see that. And not only, this is not just like a file upload or something. Yeah, you have the file content there, but even better, you have, right? You have branches if you push those, and you have the entire commit history, right? You can have a look at that commit, what changed here. You see it. So not only are the files there, but the entire version history is there. So if you go to some project on GitHub, just look at that. See what changed in the last week or something. You can do that, no problem. Now, one last thing, how do we get the changes? Say people know about this repo, they add this repository as their own origin, they make some changes, they push them there. How do you get those? Now we can make a change real quick over GitHub directly. We can say edit this file and we add GitHub content, okay? And this, again, does nothing new. It's just basically git add, git commit in the background. We say add GitHub content, whatever, and commit the changes. Now, there's a new Okay, whatever. So we have a new change. There's a new commit, right? We added the branchy content. If we go back to our local repository, is that stuff in here? Nope, obviously not. There's no GitHub content. Is our file up to date? No, it's freaking not. There's no GitHub content. Why? Because we haven't gotten those changes yet. So let's do that. Git pull. Again, origin, where, what, master. And then it again says some stuff. Yeah, we fetched some stuff, blah, blah, blah. We fast forwarded, and there's a change to new file. So now we have our changes. And we can see there's GitHub content. That's me. There's, if you're wondering why this is different, it's just because I haven't set up Git properly on this machine. Well, sucks to be me. Good, so we pulled our changes. Our new file also has the changes. Everything's perfect. So I hope you can see how that helps you to collaborate, right? If you haven't checked out GitHub, if you don't know about it, please do. It's super helpful for beginners. You can see other people's code and share your own, which is super helpful. Good. Now, I mean, that's pretty much the end. No, it's not. This is the freaking beginning. We haven't even scratched the surface with Git. I mean, what I showed today is what you will probably use 90% of the time if you work with Git as your daily driver. But the other 10% are kind of tricky, right? So there's so much more to learn. We haven't covered stuff like UI clients. I've been working in the command line. Maybe that's not your thing. Maybe you want to use something that looks nicer. Okay? I think that looks nice, but you know, taste is different. What happens when a merge doesn't work out because there's some changes that don't mesh together? You can do other stuff with the history, all manner of stuff. Please have a look at that stuff. Just Google it, figure it out for yourself. There's simply not enough time to figure that out. There's some additional resources I'd like to leave you with, especially the Git branching thing. That is, you know what, I'll just show it real quick. So this is like a little game thingy, and it teaches you how Git works in the background. So what's ahead? What does that mean? Where's your head currently? What happens when you merge for real? What happens when you pull for real? That kind of stuff. Very, very, very helpful. No. Right. So last slide. Promise. I don't know how much time I actually took. We talked about what version control is. I hope that's pretty clear. It's just the management of changes, of versions. And, well, how to Git, right? We scratched the surface there, but you saw how you can add versions, how you can navigate those, how you can basically do time travel, go back to the future, whatever. And also how you can use branches and remotes in your daily work. Okay, so that's it from me. Thank you very much, and I hope you have a lot of questions.